All right, let's take a look at number 28 on the English section here. Which choice most effectively introduces the information in the paragraph? So the first thing we need to do is look at what the following sentence or the rest of the sentence gives us. De Klerk and de Keyser suspected that the key might be the way sound waves reflect or break apart when they encounter ridged surfaces. So sound waves reflect or break apart, ridged surfaces. And so that's giving us some context. Now this is the opening part of a paragraph, the opening sentence. So let's go back and see what the ending sentence of the last paragraph mentioned. Since actors remained audible under all of these conditions, the mystery of the theater's acoustics endured. So the theater's acoustics, actors remained audible. Okay. So those are the concepts that we need to branch in between. Let's look at the answer choices here. In considering the primary source of the theater's sonic properties. Okay, theater's acoustics and sonic properties, that matches up. Does that lead into de Klerk and de Keyser with their suspicion that sound waves suspicion that the key might be the way sound waves reflect or break apart? That, I think, looks good. Let's keep checking and see if there's something better. Sensing that the ancient Greeks and Romans had admired the theater's design. We don't have ancient Greeks and Romans admiring the design. That may be elsewhere in the passage, but it's not here. Even though the evidence suggests that the Greek builders of the theater did not understand acoustic principles, it doesn't mention that there. And then D, curious about the effects of background noise on the sound quality, that's good, sound quality of the ancient outdoor venues such as Epidaurus Theater. Okay, it doesn't specifically mention Epidaurus Theater in those sentences. And the background noise isn't mentioned, although they do mention sound quality. That's close to theater's acoustics or sonic properties. But there are a couple parts here in D that don't work, so the only one that works here is A. Considering the primary source of the theater's sonic properties. So the primary source would be the way they reflect or break apart when they encounter ridged surfaces, and it refers back to the sonic properties of the theater in there. And so it matches both ends of that. Let's look at 33. Paragraph location. To make this paragraph most logical, sentence 7 should be where? So let's look at sentence 7. At Epidaurus, the combination of virtual pitch and sound dampening effect of the seats allows performers' voices to be fully heard and clearly from any seat. Okay, so we mentioned at Epidaurus, and it's a combination of virtual pitch and sound dampening effects, and they allow performers' voices to be heard fully and clearly. So let's look at those locations. All right. After sentence 6, when exposed to speech that lacks its typical lower tones, the human brain automatically reconstructs the missing frequencies. I don't think that makes a lot of sense right after. Well, let's see. We're going to have to look at some more context here. Now, I do see within sentence 7, we have two things. It's a combination of virtual pitch and sound dampening effects. Let's see where those are mentioned and then figure out from there where they should follow up. Okay. We have virtual pitch and sound dampening effects. Let's see. So we have low frequency sounds are reduced when bouncing off the seats, whereas high-frequency sounds remain unchanged. Okay, so that sounds like sound dampening. Performers' voices also contain low tones, and they are muted by the theater seats, but this sound reduction, again, we have the sound reduction, doesn't impair actors' audibility because of the neurological phenomenon called virtual pitch. This capacity helps people hear human voices more clearly. So they've introduced and explained both virtual pitch and sound dampening up here. So if that's the case, then our options for sentence 7 are to either follow after both of them or before both of them. And so what we want to do is look at sentence 7 and see if it sounds more like an introduction or a follow-up. If it's a follow-up, it should go after both. And if it's an introduction, then it should go before them. So what are the options for before? Well, let's see. Where do we have the beginning of the sound dampening? Low frequency sounds, reduced bounce off seats. So that's up here. And our options are where it is now, which would be following both of them, before sentence 1, after sentence 1, or after sentence 2. Let's check after sentence 2, so between 2 and 3. Low frequency sounds such as wind, rustling trees, other noises coming from the area are reduced when they bounce off seats, whereas high frequency sounds remain unchanged. Performers' voices also contain low tones. Okay, this is keeping 2 goes right into 3 here. We have low frequency sounds from nature and then low frequency sounds from the actors' voices. So those 2 would go together. Let's check after sentence 1. This filtering effect explains why performers are easy to hear. Low frequency sounds such as wind, rustling trees, and other noises coming from the area are reduced. So this is telling us how that filtering effect works to make performers easy to hear. So I don't see a gap between 1 and 2. And then if we put sentence 7 before sentence 1, ad epidaris, the combination of virtual pitch and sound dampening allows performers' voices to be heard fully and clearly. This filtering effect doesn't follow from sentence 7 very well. Let's take a look and see if the paragraph before it ends with the filtering effect. Sounds with frequencies lower than 500 Hz are significantly damped, while higher frequency sounds are reflected with little diminution. So that's the filtering effect being referred to. So we can't put sentence 7 in between the end of the paragraph and the beginning of this one. And then that also means that the sound damping is discussed even earlier, which means there's nowhere for us to move this up because we'd be putting it in between the sound dampening and the virtual pitch. So the only place it can go is after both of them. Which choice provides the best transition from the, 43. So we have though as a result. Now what we need to pay attention to, this is a test of punctuation. So consumers are not the only ones for whom solar power is a win-win scenario. What is that? That is an independent clause. But let's see if though can be included in that. So we do have this comma here is stuck already. So we don't have a choice on whether to remove it or not. So could that be a complete sentence on its own? Consumers are not the only ones for whom solar power is a win-win scenario, though. Yes. So we have an independent clause that ends here on though. And so all of these have an independent clause at the beginning. Could we have, as a result, comma, of their own efforts, industry employees can meet demand for environmentally friendly service while also making good living for themselves? That doesn't work. Let's look at B. Consumers are not the only ones for whom solar power is a win-win scenario, though. As a result, comma, of their own efforts. So I don't like B here because we have as a result, comma, of their own efforts. That doesn't make sense to break up that dependent clause with a comma here. As a result, comma, of their own efforts, comma, because then you're treating of their own efforts as, you're either treating as a result or of their own efforts as non-essential clauses, and that doesn't make sense. Neither one of those would make sense. Let's look at C. Consumers are not the only ones for whom solar power is a win-win scenario, though. Okay, independent clause. As a result of their own efforts, okay, that's a dependent clause that makes sense. As a result of their own efforts, comma, industry employees can meet demand for an environmentally friendly service while also making a good living for themselves. So we can have independent clause, colon, and then we have a dependent clause, comma, independent clause. And colons do allow that, so that does work. And then again, we have another as a result, comma, and those don't make any sense in there. Okay, let's go on to the math. So it looks like we have a table here of values, and we have our x values here, and for each function, or for the function f, here are the values. If a is less than b is less than c, what does that mean? Well, that means as we go here, it's going to go like this. Now, it might be curved, it might be something like that, but this point A, 1A will be lower than B, which will be lower than C. And so they're saying which could not be the graph. Well, A fits that, C fits that, D fits that. The only one that doesn't fit that is B, because from 1 to 3, it should be going like that, and that's the only one that doesn't follow that. It's possible you missed it because you did not circle or notice the not in there. Okay, so we're looking at number 28. The equation above has no solutions, and a is a constant. What is the value of a? So this has no solutions. Let's distribute this out. Negative 3ax minus a equals, plus x equals 7x minus 2. We're going to subtract x from both sides, and we'll get negative 3ax minus a equals 6x minus 2. Now, we could just plug these in, but one way to realize that we have no solutions is to treat them like parallel lines with the same slope. And if we do that, and for us to do that, we would pick a equals 2, and then we would have negative 6x minus 2 equals 6x minus 2. Let's see. Oh, sorry, wrong number. We need negative 2 in there. A equals negative 2 because we have to have positive 6. So if we do that with negative 2, we get positive 6x plus 2 equals 6x minus 2. And if we simplify that out, we get 2 equals negative 2, which means we have no solutions. So one way is to treat it like parallel lines with the same slope but different y-intercepts, because then we can have no solutions that way. Or it's to realize when you're solving for x, you get a number or an answer that doesn't make sense. Okay, now we have another table of values looking like x and y values. Okay, but we have an exponential function. Which of the following could be values of a and b? Well, a is the initial value, so that's going to be 120, because with an exponential function, the initial value is the coefficient in front of this. And then b is part of the exponential value. And so we've got to go back to the function. Let's see, the mass in d days. So basically we're doing b times the number of days. And so we can plug in numbers here to see which one could work. But first let's start by, let's see, if we have 120 times, let's just put in a number here that makes this easy for us to calculate. Since this is a calculator section, we could do 10 to the 60 times something. So we'll put b, and that's got to equal 88.78. 10 to the 60 times b equals, and what we're going to do here is round this to get a good idea of what the answer is. So 88.78 divided by 120 is about 0.74. So already we know that we need a negative exponent in here. And so at this point we could plug these two in for b and try them out and see which one gives us our correct answer. And then if we do that, we can see the closest value is -0.0022, which would give us answer D.